Hey, welcome to More Math with Kristen Morales. Let's go ahead and talk about central angles and arcs. When I think central angles and arcs, I think pizza, because pizza is a circle that is cut from the center, and a central angle is an angle who has a vertex at the center. So if you take a look at angle APB, that slice of pizza, it's cut from the center of the circle, and it is a central angle. So you could say that an example of a central angle is angle APB. So APB is a central angle. And how big is it, and how much crust am I going to get? Well, first of all, a complete circle has 360 degrees. So if you take a look at how many slices there are, let's go ahead and count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 slices of pizza. So if you take that 360 degrees and you divide by 10 slices, each slice is going to be 36 degrees. So this is a 36 degree slice of pizza. That means the measure, put a little m in front, of the angle APB is 36 degrees. Now, however big of a slice of pizza you get, however big this central angle is going to determine how much crust you have. So arc AB is your crust. So an angle, a central angle, also creates an arc, right? And the arc is determined by that central angle. So you would say the measure of that arc equals 36 degrees. So a central angle is an angle with a vertex at the center of the circle, and the arc is a portion of the circumference, which is the edge of the circle, and it has a measure equal to the measure of the central angle. Let's go ahead and talk about different kinds of arcs. We have minor arcs, major arcs, and semicircle. So a minor arc is just a small arc that's less than half a circle. So here on this first pizza, I have a picture of a minor arc because this arc here, you can see, is less than half a circle. Let's go ahead and give that arc a name. Let's call it arc QR. And actually, let's go ahead and put a point P in the center, so point P. So we'd say arc QR is a minor arc. Now, a minor arc has to be less than half a circle, and this is a 72 degree angle. 72 degrees is less than half a circle, so QR is a minor arc. Now, if you look at my second example, this goes through the diameter of the circle. See, there's the center, so it goes through the center, so this is the diameter. And when you have a diameter, it cuts the circle in half, and it makes a semicircle. So a semicircle actually equals 180 degrees, so this is 180 degrees. And you can say for that one, let's call that, I don't know, let's call it arc AB. So you could say arc AB forms a semicircle. So a semicircle, half a circle, 180 degrees. Now, if I put some points on this one over here, let's call this point C and call that point E. And I told you to draw arc CE. You wouldn't know if you were going to go this way up top, or if you're going to go down here and go on the bottom, unless somebody told you they want a minor arc or a major arc. Now, a major arc is an arc that's more than half a circle. It's greater than 180 degrees. And if I wanted to go this way and make a major arc, I would come down here. Notice I'm passing through a third point. And if I wanted to go that way, I would need to put a third point here, so people know that I'm going to make the major arc. I'm going to start at point C, go towards point D, and end at point E. So if you want a major arc, you're going to name it using 3 letters, and that's how you'll know which way to go. So you'll say that arc CDE is a major arc. and that one's 216 degrees. You can see it is bigger than 180. So we have minor arcs, major arcs, and semicircles. Now, the next thing I want to look at here is vertical angles. Okay, so let's go ahead and talk about vertical angles and arcs. So we already know that vertical angles are congruent. Vertical angles happen when two lines cross. And you can see when you're cutting this pizza or cutting this circle, if you go through the center of the circle, right, you create a couple diameters. So here's the center of the circle, and these two diameters create vertical angles, and that's actually how you slice a pizza, right? So these two pieces of pizza both have a 45-degree angle. And if you have a 45-degree angle, the central angle, then that must mean the corresponding arc, which is the crust of the pizza, is also 45 degrees for this slice and 45 degrees for this slice. Again, when you're thinking angles, you're thinking the actual cut of the pizza, and when you're thinking arcs, you're thinking the crust of the pizza. So these two slices of pizza have the same central angle and the same amount of crust, which is 45 degrees. So if I gave this arc a name, let's call it XY, let's call this point Z, and call this one QR. We could say that the measure of angle XZY equals the measure of angle QZR, right? They both equal 45 degrees because they're vertical angles, and vertical angles are congruent, but also those two pizzas have the same amount of crust, right? So arc XY, or the measure of arc XY, equals the measure of arc QR. Those both equal 45 degrees. Okay, I think we are ready to solve some problems. Let's go ahead and give all this a try. Let's go ahead and try problem number 1, where we're going to try to find the measure of an arc. Okay, first of all, remember the arcs equal the central angle. So if you see an arc like this 78-degree arc, go ahead and bring it to the middle, because the central angle equals the arc. Now, I want to go ahead and find the measure of arc DCF, so I want to find some of these missing angles. And the first thing I'm going to look at is I'm going to say, well, can I go ahead and find this angle here? Well, yes, I can. So I'm going to say this is a semicircle. I know a semicircle is 180 degrees, and if I subtract that 58 and the 78 that I already know, I end up with 44. So that means that this central angle right here is 44 degrees. Now I can go ahead and keep looking for semicircles to find missing angles, and if I look right here, I have another semicircle, which I know is another 180 degrees. I have this little part that's 44, so if I subtract that 44 degrees, I end up with 136 degrees. So this angle here is going to be 136 degrees. Now I have almost everything I need here to find the measure of arc DCF. So the arc that I'm trying to find here is arc start at D, go in the direction of C, and end up here at F. It's going to be a major arc, DCF. And the arc equals the measure of the central angle, so the angles are 78 plus 44 plus 136. So if I add up all the central angles, I'm going to get the angle, which will be equal to the arc, which will be 258 degrees. So measure of angle DCF is 258 degrees. All right, so not so bad. Let's go ahead and try number 2. For number 2, I'm trying to find the measure of angle JHL. I have this arc JK, which is 65. I'm going to bring that into the center. It's going to be the same as the central angle. Remember, the arc equals the central angle, so the central angle is 61. And I want to find JHL. So if I look for a semicircle, I can see that this is a semicircle, half a circle is 180 degrees, and if I subtract the 61 degrees and the 65 that I already know, I end up with 54 degrees, which is here. So now that angle's 54 degrees, and I want to find the measure of angle JHL. So this is a central angle, and by angle addition, I can just add the 65 and the 54 degrees. So if I add these together, 65 plus 54 is 119 degrees. So this angle here, angle JHL, is 119 degrees. All right, let's just try a couple more problems. I have the measure of angle DAF. Okay, so where is DAF? Okay, so start at D, go to A, go to F. There's angle DEF. I can see that this arc is 40 degrees. The arc equals the central angle, so the central angle is 40 degrees. This arc is 60 degrees, so the central angle is 60 degrees. And then by angle addition, if I just add the 40 and the 60, I'm going to get 100 degrees, and that's going to be the measure of angle DAF. All right, let's try one more problem, number 4, the measure of angle SQU. Okay, so here is SQU. Let's try that one out. Okay, so this arc is 52 degrees, so the central angle is the same as the arc, 52 degrees, and this arc's 52 degrees, so this central angle is 52 degrees. I need to find this missing part. So if I look for a semicircle, which I have one right here, remember a semicircle goes through the center of this circle. It has a diameter. It's 180 degrees. If I take 180 and I subtract the 52 and the other 52, 180 minus 52 is 76 degrees. So this is 76 degrees. Now I have everything I need to figure out the angle. And I'm going to go ahead and say the measure of angle SQR by angle addition would just be the 52 plus the 76. And if I add those together, I get 128 degrees. So the measure of angle SQR is 128 degrees. Okay, so there you know a little bit about central angles, and there's a couple problems on the problem set that you can try for homework. I want you guys to try numbers 5 and 6 for homework, and then we will also go over it next time in class. All right, take care.